Hello everyone, this is Shivam Deshpande and I am going to show you the task 2 of the Data Science and Business Analytics internship at the Sparks Foundation. So the task 2 is prediction using unsupervised machine learning algorithm. Let me quickly show you the task. Yes, so this is the task 2. Now the problem statement is from the given iris dataset, we have to predict the optimum number of clusters and we have to represent it visually. Okay, so this is the data set that we have provided, the iris data set. It contains four columns: sepal length, sepal width, petal length, petal width, and one column of species. Okay, so this is the data set that we have given, and we are going to use the clustering method here. So let me just quickly show you. Yes, so let me quickly give you the overview of clustering. Right. Clustering is a process of dividing the data set into groups that consist of similar data points. So basically, the algorithm divides multiple data points and it collectively creates a cluster, and the cluster will consist of similar data points. Okay, so points in the same group, they are as similar as possible, and points in the different groups are as different as possible. Okay, so the data points within one single cluster will have much similarity and they will be correlated. Okay, this is the unsupervised machine learning technique. Now you can also find some real life applications of this clustering. So the recommendation system, the recommendation that we see on Amazon. Okay, so the recommended products. So the Amazon provides recommended products based on or using this technique. It tracks your past purchase history, and based on that it gives you the recommended products. Even the Netflix also recommends you the movies based on your previous watch history. So these are some kind of real life applications of clustering. Uh, the one process of clustering, which is k-means clustering. So the k-means clustering we are going to use here in our data in our code. So k-means clustering is an exclusive type of clustering method. So what do we mean by that? So the data points or items exclusively belongs to one single cluster. Okay, so this is nothing but a exclusive clustering. So the clustering in this clustering, one single cluster will have the data points which are correlated, and they will not have any relation with the data points of other clusters. So this is the exclusive clustering method. The clustering applies to numerical continuous data. Okay, so in k-means clustering, the k refers to the number of clusters, right? So clusters, the number of clusters that we want to create represents the k. Okay, so these are some steps of k-means clustering. Okay, these are normally followed during the algorithm. So firstly, we select the number of clusters that we have to form, that is k. Okay, after selecting K, we select the K data points as initial cluster centroids, right? So to form clusters, we initially need to select some random data points from the data set given, right? And we call them as cluster centroids because they will be the first data point in that cluster, and further points that we are going to add, they are with reference to this point. So they are called as cluster centroids. Okay, now while adding the new data point, what we do is we measure the distance of this new data point from the center of clusters. So cluster centers of multiple clusters, right? So we measure the distance of this data point from each cluster centroid, and we add the data point to a particular cluster based on the measured distance. So the distance which is less to the particular cluster center, we will add the data point to that particular cluster. Okay, so this is the k-means clustering, and these are the steps which are normally followed in k-means clustering. Okay, with this overview, I will move on quickly to my code. Right, so this is the Jupyter notebook I've used for coding. Okay, we'll quickly go through the code. So I have imported the necessary libraries. First of all, so NumPy, Pandas, Matplotlib, right, sklearn for importing the k-means and running the algorithm. Okay, the iris dataset I have already shown you. So that dataset we have loaded here. Okay, so you can see the first 10 entries of the dataset here. As I just told you, the columns and so sepal length, sepal width, petal width, species are the columns in the dataset. Now we'll explore the data. So we find the shape of the data. So there are 150 entries, and there are six columns over here, including the ID column as well. Okay. Now this ID column is the redundant column, as we have these labels also to show you the entries, right? So we don't need this ID column. So we are going to remove this ID column using this line of code. Okay, so here you can see that ID column has been removed. This is this is one of the steps in data cleaning. Okay, uh, then we find out the information about the data set. So the number of columns it has, then it also gives us a non-null count. Okay, this shows us that there is no null value or there is no missing value in our data set. Okay, our data is cleaned. Okay, and this also shows you the data type of a particular column, entry in the column. Okay, and this is the describe function, so it gives us the statistical information about our data set. So the mean, then min and max values, then the percentiles, that is 25th, 50 and 75th percent, and it also gives us the count of the entries in particular column. Okay, so this was about the data set. Okay, now what we'll do is we'll find the optimum number of clusters using the elbow method. Okay, so I just told you the steps of k-means clustering. The first and very important step in k-means clustering is to find the number of clusters, right? So we have to find how many number of clusters we are going to create for our data set. It depends on our data set, the values in our data set. Okay, distribution in our data set, number of values that it has. Based on all such things, we first decide how many clusters we want to do. Okay, that will be efficient. Okay, there are many methods for the same, and one of the method is elbow method. We are going to use here for deciding how many clusters we want to create. Fine, so this is the elbow method. Okay, in elbow method we define clusters such that the total intra cluster variation, or the total within cluster sum of squares, is minimized. It is WCSS. So what it is? So intra cluster variation is nothing but the variation between the data points in one single cluster. Okay, so the data points in one cluster should have a very less distance. They must be correlated more. Okay, so WCSS should be minimized. Okay, WCSS is nothing but the cluster square, sum of clusters square, or intra cluster variation. This variation should be less. So WCSS should be less. So this method basically defines clusters such that this WCSS is minimized, and this measures the compactness of clustering. Okay, we want this WCSS to be minimum as possible. Okay, so the elbow method looks at WCSS as a function of clusters. These are the steps of the elbow method. So what the elbow method does is, first of all, it compute a k-means clustering algorithm by using different values of k. Okay, so we are going to iterate here k from 1 to 11, right? So for each of the value of k, the algorithm computes k-means clustering. Okay, it runs k-means clustering algorithm for multiple values of k running from 1 to 11. Now, for each value of k that we have considered, it calculates the total WCSS, the intra-cluster variation. Okay, then what it does is it plots the graph. Okay, the graph will include the number of clusters on the x-axis. Okay, the clusters, that is 1, 2, 3, 4, 5, 6, 7 up to 11 we are going to use here, and on the y-axis it will have WCSS. Okay, so it will plot this graph, and by visualizing the graph, the location of a bend or a knee in the graph. Okay, it gives us it will be some number, and that number will be the optimum number of clusters in for our given data set. Okay, so that many number of clusters we should create. Okay, so this is the elbow method that we are going to see. We are going to look in here in our code. Okay, so we have used this elbow method. Okay, WCSS, we have just initialized an array and it will contain the values of WCSS. We are iterating from 1 to 11. Okay, and in each iteration the number of clusters will be I. Okay, so the number of clusters will be k will be equal to I, that is 1 to 11. And after that we'll fit our data using this, and we'll append the WCSS, this matrix, with the number of clusters, inertia. Okay, so you can see that we have plotted the graph, as I told you. So this is the graph of the number of clusters versus intra-cluster variation. Okay, so by seeing this graph, you can see that this is the elbow point. Okay, this point gives us the optimum number of clusters that we should create. Okay, so this point is 3, right? So this tells us that the optimum number of clusters that we should create is 3. Okay. Yeah, so now by applying this algorithm to our data set. Okay, so this time now we consider the k value as 3. Okay, we have predicted that k value should be 3, and with this 3, with the k value equal to 3, we are running the algorithm to the data set. Okay, so again we are creating clusters. Okay, so this is the code for creating the cluster. uh, Clusters are created in this code, and this is the code for visualization. Okay, so with this code, using the plt, that is matplotlib, we are visualizing our clusters. Okay, so with this graph you can visualize the clusters. So it shows you basically the species of the iris, and this yellow colored dot gives you the centroid of each cluster. Okay. Okay, so this was for sepal length and sepal width. Similarly, we have plotted the graph for petal length and petal width. Okay, so from here also you can view the different species, the clusters, and the cluster centroids. Yeah, so that's pretty much it in the code. Thank you so much.